It is also important in the study of pharmacology to understand what pharmacodynamics means in reference to drugs being delivered to a patient. In the previous chapter, we looked at what pharmacokinetics is, which is what the body does to the drug. The body absorbs it, distributes it, uses it therapeutically, hopefully, metabolizes it, and excretes it. Pharmacodynamics is defined as what the drug does to the body. So more specifically, looking at what the drug does. Is it providing a therapeutic effect? Is it providing a toxic effect? Is it providing a negative effect? Pharmacodynamics is also referred to as the drug's mechanism of action. So what activity is it demonstrating in the body? Pharmacodynamics is looking at how it changes the body, and we as nurses need to be knowledgeable about all effects, both therapeutic as well as adverse effects that we also call side effects. Another factor that plays a role in the pharmacodynamics of the drug, or how the drug is affecting the body, is relating to what we call the therapeutic safety index of the drug. The therapeutic safety index describes the drug in reference to its level of safety in titration. This is a mathematical factor that is determined when the drug is studied in clinical trials by the pharmaceutical company. And therapeutic safety index is often abbreviated TI for therapeutic index, and it might be abbreviated in the literature that you're reading about drugs. When the drug is studied, the drug company determines two different levels that play a role in the safety index determination. One is the minimum effective concentration that kills a living organism. So one factor with an adult would be the level of drug in milligrams that is lethal. So the lethal concentration of the drug. And that becomes the top number. The bottom number of the safety index mathematical determination is the amount of milligrams that provide a therapeutic response in the body. Okay, so the number of milligrams that was studied to be therapeutic in a human. So the therapeutic safety index takes the number, which is the lethal dose, and divides it by the number, which is the therapeutic dose. When that number is divided out, that number is determined to be the therapeutic safety index. A therapeutic safety index that is really large in number, we call that a very wide or broad safety index. A number that is very small is considered to be a very narrow or small therapeutic index. Again, when we meet on later in this week, I will do a diagram of this to show you mathematically if you're not following my verbal example. Think about a lethal dose of a drug that is 100 milligrams. Think of a dose of that same drug that is therapeutic, maybe 10 milligrams. So if we divide 100 milligrams by 10 milligrams, we get the factor of 10, the therapeutic safety index of 10. If we think of another scenario where a drug has a lethal dose of 10 milligrams and a therapeutic dose of 9 milligrams, if we divide 10 divided by 9, we're getting a number close to 1 point something. So the first scenario, we have a therapeutic safety index of 10. Second scenario, we have a therapeutic safety index of 1 point something. The safety index of 10 is a broader, wider therapeutic index. Therapeutic index number of 1 is a narrow, smaller therapeutic index. Think of these numbers in relationship to titration. In the scenario where 100 milligrams kills a person and 10 milligrams is therapeutic, we have from 10 milligrams up to 100 milligrams to safely titrate up the dose in order to achieve the therapeutic response for that patient. That's a fairly safe therapeutic index. The scenario where 10 milligrams is lethal and 9 milligrams is therapeutic, we only have from 9 to 10 to titrate safely to get the patient to be therapeutic if they're not at the 9. So a very small, narrow margin of safety. Clinically, a large therapeutic index is going to allow the prescriber to be more liberal in increasing the dose. A narrow therapeutic index, the prescriber is going to be more cautionary, and you're going to see increments of tenths or hundredths, 0.1, 0.01, or very small titrations of drug to get to the level of therapeutic need. In pharmacodynamics, there are two other terms that are important to consider. One is the potency factor, and the other is the efficacy factor. In real life, potency doesn't play much clinical importance because whether a drug is more potent than the other drug is not really what matters to the patient. What matters to the patient is, was the drug efficacious? Was it helpful for their symptom? So potency is a milligram to milligram comparison of one drug to another. Let's think about taking care of a headache. We've all had headaches. You can take ibuprofen for a headache, or you can take acetaminophen for a headache. Ibuprofen is generally dosed at 400 milligrams over the counter for a headache. Acetaminophen is dosed at 650 milligrams to treat a headache. So if we compare milligrams to milligrams, ibuprofen, 400 milligrams, to the acetaminophen, 650 milligrams, it takes less milligrams of ibuprofen to treat the same headache. So ibuprofen, we could say, is more potent of a drug than acetaminophen. However, if in the patient's body acetaminophen works better, who cares? The patient certainly doesn't care which one is more potent. We're going to go to efficacy. Efficacy is the response obtained from a particular drug. This is what we care about clinically. So it doesn't matter what is more potent. What matters is what helps the person feel better and take care of their symptom.